Hi, my name is Ivan, and I want to present you my next Max for Life device that I've been creating in these 3 weeks, probably or more. It's basically a controller device for MIDI and OSC that is basically designed thinking all the time in the push-3 integration. So basically it's going to work with also Max and Max for Life alone, but this thing has been created in order to be able to control different parameters on MIDI and OSCs in the push-3 standalone. As you see, I have my push-3 right now connected in standalone mode, so I'm going to add the device, which I have here in the orange section in the last one, so push-3 OSC MIDI. You will notice that as soon as I load the device, something will happen, that probably the name of the track has changed and also the master color has changed. You can see that because right now we are in the push-3, but in the Max for Life device the master track also changes its color. The thing to change the track name is just because it will interact with other Max for Life devices I'm really developing right now, and I just wanted to have a single name in order to, for example, with the preset starter, not to really see the things stored in this device, in order not to change the IP addresses and anything like that, because it will probably cause problems. So the first thing was to create something to change the name of the track itself, in order for other things to realize that this track cannot be stored or cannot be changed. So as you see, we have a page scroller, so we can scroll from different spaces in the device itself. That was an idea came from Isotonic Studios. In order not to have to push buttons just by scrolling the page, we can access all the different parameters in the device, which is something really convenient. The other thing is that we have different sections, and we will start probably by explaining what this thing is doing really. This device is really connecting the push-3 with other things, and other things with the push-3. It also applies with the Max for Life installed in a computer, on a Mac, on a Windows computer. It basically connects all those different worlds, and when we connect by using OSC messages, we basically need two things for each connection. First of all, if we are going to connect our push-3 with other devices, we need to know the IP address of the device that we are going to connect to. And this is done by basically going into the device. I have right now here with me my mobile phone. Basically, you can access to different applications or programs. In this case, let's say we have an iPhone, or I think in Windows is working that way too, but we can go to Finch, and with this application we can get all the IP addresses on the network we are working, in order to know what this device is, what IP address this device has. So Finch is a good idea to have, just in case you are going to use all those things, because it will give you all the IP addresses on the network. So basically the Max for Life comes with a config file. This config file will be stored in the push-3 standalone, and it will be stored in a folder called config with and then the name of the file. The name of the extension of the file, it's ALC, in order to being able to see that device inside Ableton Live, because if we store configurations in TXT files or anything like that, we won't be able to see that those files inside Ableton. So I decided to use the Ableton naming in order to being able to see that. Although the ALC files, this config.alc won't be really an ALC file inside Ableton, but just for being able to take this file in editing, I think it was a good idea to have that way. So in this config file we'll have different presets and different namings in order to being able to configure all those information to adapt for our own system, because the IP addresses will change from one computer to another, from one push to other, and one network to another. So in this case, we have right here a scroller, so we can see different namings. And in this case, I have basically at home 3 different devices, which is a Mac, an iPhone, and Windows. And then I have also 3 kinds of connections. I have Wi-Fi, a home network, and then we have an iPhone hotspot, something like that, and then we have local. So those 6 first items, which is Mac at Wi-Fi, iPhone at Wi-Fi, Windows at Wi-Fi, or Mac at iPhone, iPhone at iPhone. So those 6 different configurations, we will be able to change that in the config file in order to introduce our own IP addresses to being able to connect to our own devices. And the locals, just in case we want to connect our push 3 to other devices using Ethernet cables, so wire connection, which is for OSC, I think is the best solution. It gives you really a huge amount of data, really fast, accurate, and without losing or dropping information in the meantime. Because if you are using a home network, it will lose probably information if you're using Wi-Fi connections, you will probably lose information. So I think the best option is to have a wire connection over an Ethernet. You only need an Ethernet adapter for the receiving device and for the sending device, which is the push 3. I will give information of all those devices that really work or are working for me. In this case, we're using a Wi-Fi. So in this case, as I want to connect my push 3 to the iPhone itself, I will scroll through the device I want to connect to. In this case, it's the iPhone connected to the Wi-Fi connection, because this thing is also connected to the Wi-Fi. So if I hit load, now this thing is sending information to this IP address over that port. And when I say in the first section that we need 2 things to connect to a device, the first one is the IP address, and the second one is the port number. The port numbers can be changed inside the push 3. What we can't change at the moment, because I think there's something wrong with the Max for Life devices inside the push 3. It's giving me a lot of crashes and problems. Is changing the port of this device when he receives information from other devices. So the receiving port is fixed with the push 3 standalone, but we can change the port for the sending device. And this case is fixed with 17,000, because the number times 100, so it's the actual port, it's 17,000. And as we hit load, now we are sending information to this device. If I move this iPhone here and we go to page number 2, now we see that in this page we see the actual CPU of the push and the track where we are right now, which is OSC MIDI, the device that we are already seeing, which is the first one, the push 3 OSC MIDI, and the device first parameter. So if we go right now to page number, as you see, by the way, here are the fixed parameters that we can introduce in the config for the IP addresses that we usually are going to be using. And in the second page, we have the actual numbers of those IP addresses. So we can change all those addresses to the one that we go to somewhere and the IP address is not, not introduced in the config file, and we want to use this as a standalone, because I've been designing this thing to be as a standalone as possible, not to use a computer at all. So we can introduce different IP addresses and then select the port and hit load, and it will connect to the IP address that we want to go. We have 2 pages for that. We have, the first and the second pages for the IP address A, and then we go to the IP address B, because probably we want to send information from the push to an iPhone or to an iPhone or an iPad, or to an iPhone and a computer running Task Designer or Notch to control visuals. Probably in the future, if if people are using this, we could introduce as many IP addresses as we want, because the push 3 doesn't have any problem with having multiple IP addresses for sending. Okay, so as right now we are sending information to the push 3, we can go to page number 5, and actually we can here change the tracks. We can go from different tracks and to select things inside the tracks. Okay, right now it says as on track 0, which is actually in the first track. In track 1 we have MIDI, but it's empty. We don't have any device or parameters to select. Then we have in the third track we have 3 audio and everything is empty, and in the last one in audio we don't have anything. Then we go to the send and to the return tracks, but anyway we have empty things there. So let's do one thing in order to know what things we can do with this. I'm going to go to the track number 3 and load a device. So let's say we want to have, let's go for the auto filter because it's a quite visual element. So right now we have a filter inside our track, and if we go to track number 3, if we go to page number 5 on the OSC MIDI and we go to track number 2, we will see that now we have the name of the track and with the auto filter selected, and we can scroll through all the different parameters. By the way, you will see some kind of lag here because I'm moving the dial and the thing is getting a little bit slow. This is because I'm connected to the Wi-Fi, the home network, and this is now downloading things. It's not really the best way to do that. The best way to do that is also have a connected network, local network. This is the best one, but probably we will lose some kind of flexibility of being able to move with our devices. So in order to go from the top option to the lower options, we will go then into a dedicated router. We can buy one small router and connect our push and all our devices to that router without having any internet connection in this router itself. So it will give us only the option to wire things wirelessly. If we go on a step down, we may have this device sharing its internet connection, and this will work really nice because then we can use the iPhone. Let's say in this case this is an iPhone. We can use the iPhone to send to connect things together. If we use that option, we will also use softwares like or applications like Finch in order to get the IP addresses of all those devices. But you can do that at home, change all the IP addresses in the config file, and then you will be able to connect whatever you are instantly without having to dial any kind of IP addresses at all. So they will be stored in those spaces. Okay, so let's go on. So now we have selected our we have the option to send information. So right now we are sending information from the push itself to the iPhone using the IP address of the iPhone. So if we go, let's check this in another way. So if we go to different tracks, and now we have, for example, the volumes. If we go to this page, by the way, this is a template that will be included with the device when picking this pack. If we go here, now you can see that the faders are moving. Okay. There's also the naming of the tracks in these vertical lines, although I need to work a little bit more on that, because not all the namings are actually being updated and they kept the last session naming, so I need to work a little bit on that. But you can see that the levels are running, and also in those green lines we'll see the levels of the tracks that we are playing. The levels are right now not moving that fast. I need to find another way, because the view meters in the Ableton, the live.object is not sending that information quite fast, so I need to find another way. I have an idea on how to do that right now, but I need to work a little bit more on that. So probably in 2 weeks or something, I will have a really fast way to know the levels of those different tracks. But right now, as you see, we have control over the levels of that we have. So we have a visual feedback, but if we touch those levels, nothing happens. Why? Because we need also, as I said earlier, we need two things to control OSC messages when we are wiring two devices together. First, in order to send that from the push to the iPhone, we need to know the IP address of the iPhone and the port, and then from the iPhone to the push. We didn't set this up right now. We didn't set this yet. So we need to go to the configuration. This, by the way, I'm using Touch OSC application, which is quite nice to have a different OSC controllers and faders. Is really quite nice, that application. I recommend to everybody to download that and try. If we go to this page, when we see OSC, we see that we have different connections, and in this case I have selected this one, and this is actually the address of my MacBook Pro. So this is why the iPhone is sending information to a different IP address and to a different port. The default port for the Push 3 standalone is 16,000 in this case, because this IP address works all the time, and I'm not having any issues with that port. By the way, that port can't be changed at the moment. While we are using the Push 3 standalone, we need to change in the Max4 Live device itself, because if we change that port while we are working, it will crash. I think this is something that people at Ableton, as I said earlier, need to work a little bit more, but you know, with 16,000 is working. So we need to connect to this device, and this device, it actually, I already know the address because I've been working a lot with the Push itself. It has its IP address set at that one, so I only need to correct one thing. I need to correct the port because it's 16,000. So once I set this up and once I go to play, if I move the sliders will move, so I can change whatever I want. And if I go to the master track, again, I can have the information of the master track here, so I can control everything, every single thing. As you see, this is quite flexible because we can have different things, and now you will see that this is really huge because we are not going to connect or to control only the volumes, faders or pannings. We are going to control every single thing inside this device. So now I've explained how to connect things together. Now we will go a step further. So, as I said earlier, as I said earlier, we have here a parameter selector for the different devices, and we can see one thing from when we move from track to track and from parameter or device from one to another. We'll see something in this blue line, which is the ID of the parameter that we want to control. In this case, we are doing this with the menu, but let's go to this page where we have installed our auto filter. So what basically we are going to do now is to assign faders. I have this, this random page. It's not really configured in a fancy way. It's just faders and sliders. And so in this case, I have created a way to assign multiple OSC parameters to different OSC names to different parameters. If we go to this page in the touch OSC, we select that fader, we will see that this fader has a naming called data 1. Okay, so what the system will do is that it will listen to the naming of this fader while we are playing it. So we touch once, and once we touch that fader, if we hit select and move the value that we want to control, now this thing is automatically attached to this value. So if we want to select now with the other one the resonance, we touch the fader, move the resonance, and we are ready to go. If we want to control the clean with the third one, we just move the fader, move the value. If we want to control the clean value, so we move this fader. Probably they have the same naming. Let me check. No. So we go to fader. Okay. So now we are going to see a way to connecting different parameters in our configuration with the touch OSC faders or dials or anything like that with different parameters. So if we go right now to this page, the fourth one, I have different faders, different dials, and different kind of things. It's not really configured in a fancy way; it's just a random faders. And if we go to this configuration page, we will see that all those faders have names. Okay, fader 2. And what the system is going to do is, if we touch one fader and then we go and hit select and move the parameter that we want to control, it will be automatically mapped into this parameter. So let's say, for instance, that we already have this fader controlling the frequency, and then we want to control with this other fader the LFO frequency. So we touch that one, select, move, here we are. And now with this one we want to control the resonance, so move that resonance, and the resonance is gone. So we have different parameters mapped at the same time in a really fast way, just by using OSC. By the way, this thing works exactly with MIDI mappings. If we connect a MIDI controller, let's say a fader 4, something like that, we have different dials, we will be able to map our controls with just by touching the CC number, the CC, the pot. It will give us a CC number, and then we will hit select and the parameter we want to map, and that's it. All those different parameters will be stored with each project. So each time that we open a new project, all those values will be included within the project itself in a different file. So it will create for us a ALC file in the same folder config with the name of the project. In this case, right now we don't have a naming. So it's really important that if we go to create those mappings, to store them if we have a naming in the file. So if we don't have a name in the file, nothing will be saved. And this is because we need to, in order to not to have a conflict with different projects that we open when we open up this push3 new empty template, so not to have prefixed values stored from the previous session where we didn't save anything. So this is just a safe thing in order not to get really confused by mappings that we didn't already make. So let's say now we have this thing controlling the frequency. If we go to, and we want to erase that, so if we want to page number 7 in the OSC MIDI and we select this fader and we delete the OSC mapping, now if we go to this page, this one is gone. So we already have those controllers, the LFO frequency, the resonance, but the filter has gone. And if we want to delete everything, just go to delete all OSC maps. By the way, this reload OSC maps is just because, just in case we made a project, we load the project and we want to reload the config file for that project, we just hit reload and we will reload all the mappings. But right now I need to rethink about a little bit of that, because I don't think this makes much sense, because right now if we have already saved file project with a name, all the configuration will be automatically stored. So it doesn't really mean that much. It doesn't make sense to have that kind of reload OSC maps, because the reload OSC maps will be the last saved ones that we have, so it will make no sense. But anyway, I need to rethink that option. I think it's better to have automatic parameter saving, just in case we close the program, or we close the push. So it's better to have all those data automatically saved. Okay, so if we want to remap this little thing to other place, we just touch the fader and select resonance, and it will be automatically mapped to the resonance. So it's really fast. We can only map one fader to one value at the moment, because this is not really mapping anything at all. I'm working with tables, so in those tables right now we only have two columns, one for the value and one for the parameter itself that we want to map. So it's not possible to have multiple parameters at this point, but probably in the future I will implement that. At this moment it's not possible. Okay, so here we are with the fader Fox connected to the push 3 standalone. Right now in page 5 we are back to our track and device and parameter selector, and as you can see, if I touch the different pods here, you will see the CC number also in this little screen. You can see the number of the CC value that it's coming into the push. Okay, so if we have this CC number selected and we go back to the controller that we want to move, and we hit select and move the parameter, now this parameter is going to be controlled with the CC value. Okay, it's automatic. So if we want to control, let's say this, so for instance, if we want to control this complete row of different values with, let's delete that, with delete all CC mappings. Okay, if we want to control that complete row with this complete row values, is as fast as going that, selecting, moving this, selecting this, selecting this. Oh, this is already map, sorry. This, and now we have all the different things connected in that way. So, and as I said earlier, all those different parameters are stored within the config folder with a special naming, which is basically the name of the project with I think it's underscore something like OSC MIDI.alc. But those mappings won't be safe until we have a project with a name. So if we open the push, we load the Max4Light device, we start making some mappings and anything like that, anything won't be saved into the device until we hit save and we have a name, and then we move another parameter, so the parameters are going to be automatically stored into the system within ALC file. So it's important that once we have a project, to save it, and all the parameters will be saved. This is I think is a really nice idea, because instead of having a project with all the parameters inside, we will have an ALC file, which is basically a TXT file that we can open with a TXT editor with our computer, or with any kind of a program, and we will be able to change the numbers and map them to another parameters just by changing the name of the parameters inside the file. So if we want to copy those parameters, let's say that we have one project and we want to have multiple configurations of MIDI parameters or OSC parameters, we just can duplicate those ALC files, and we will be able to have multiple configurations to be used in different situations. And the reason for that page, because I've been talking a lot of the times of that page, it doesn't make really sense to have that kind of page with all the information. Well, okay, it's nice, but what can we do with that? Okay, so if we are mapping a CC values, let's say that we are, in an airplane flying to wherever we want to go, and we don't want to have the fader fox connected to the push tree in order to do the mappings, because we already know that our fader fox has, in this case, CC mappings in the naming of 0, 1, 2, 3, 4, 5. So as we know the configuration of the device itself, we can just go simply by selecting parameters and assigning them to the values that we want to add. And the way to do this is, let's say that we know that this parameter is number 0, okay, and we don't have the fader fox connected anymore to our push tree. So let's say that we want to control this parameter that is not really connected to the push itself, but we want to be able to use when we have the fader fox with us. Right now we don't have the fader fox, so we will go to OSC, and we just can select the CC number. In this case it's going to be 0, and then we can do different ways to do that. We can just scroll through the different parameters just by selecting Shift. We hit Shift in order to have a more detailed movement of the spots, because sometimes they are quite sensitive. And then we go, let's say that we want to control the, okay, let's try the envelope attack of the auto filter with the CC number 0. Then we hit Store, and that's it. That's stored in the config file. I mean, it's not really stored, it's stored inside the table. Right now it's not stored inside the push 3 because we don't have a name for the project right now. But this device has been attached to CC number 0. If we go now and connect the fader fox, the fader fox is once again connected. If we go to the auto and we go to the envelope attack, if we move this dial, it's responding, and we didn't hit that pot at all to being able to map that. Okay, so this is why this thing could be useful. I mean, I usually try to create different ways to approach the same problem, and because sometimes we will have option to do the mappings with the select, but we can also have this kind of information over the tracks and the devices, and it's really nice. Or we can just take notes. By the way, the IDs of those devices and those parameters inside the push tree change from one project to another. So if you open a project, an empty project, and you load an auto filter, let's say an auto filter, probably the auto filter won't have the same ID as the auto filter in another project, just configured the same way. Because the IDs are getting introduced in in a continuous way, so probably the IDs won't be the same. So so don't really get confused with the IDs. The IDs will change. Okay, the parameters won't change and the OSC names won't change, but the IDs will change. Okay. Finally, I would like to tell you that the OSC will give you a huge palette for doing different kind of stuff. Right now it's a starting project. It will have different things. For example, yesterday I was thinking about a way to implement different ways to control things in the push tree with a mobile, and I've been thinking about I think it's quite a nice way to do that, because OSC messages can have whatever name we want. So in this case, I've been thinking about a way to automatically control things inside the push tree without having to assign name, just a simple thing. So if we go here and we select those dials, for example, let's say that we want to control the panning inside these those devices. I've been thinking about a way to do this as fast as possible, and this way is just by naming the dial in a certain way. So if we go and name this dial, let's say in LOM, and then pan underscore and then a number, this naming will be breakdown inside the push tree as soon as he receives the value, and will assign the values coming from this fader to the panning of the track number 2, and track number 2, remember, is 012. Okay, so if we go to play and we move this, you can see that this thing is working automatically with track number 2. If we go here and rename that to pan number 3, now we will be controlling track number 3 just by renaming them. We don't need to assign anything at all. They will be sending information to different things just by using the live object model, which will take the information from this naming and will be transferring to different objects inside the push tree. I will need to find the way to break those names into track activation, start record, play position, and I mean this thing is going to be really crazy, because I think I'm probably going to be releasing updates for this device every single week or two, because I have right now I have a list of ideas, probably more than 50 ideas to be implemented in this device in order to control everything. And when I mean everything, is everything inside the push tree and outside the push tree, because if we go to page number page 8, I just forgot that. We have here information about things coming into the push. So with another device right now I'm working on, we will be able to launch automatically launch different things inside the push tree just by using messages coming from another applications or from QR. I will show you that in a minute. This is really crazy, that thing. By the way, we also have in page number 8 the option to load MIDI tracks, which are going to be automatically loaded. So just in case we want to load tracks in a fast way, we can do that. And we can, when I say reload tracks, it will reload the information of all the tracks in order to have access to these parameters. Just in case it doesn't update, if we go to page number 8 and we reload tracks, it will update all the namings inside the push tree. Now we go to page number 9 and we have datas. So those datas, what is data? So data is pre-configured OSC names to be sent from the push to other things. And I will implement a list of probably 200 different OSC messages that we can send from the OSC to the push. Let's say that right now, as you see, I can move this, and this thing is assigned to this fader. Why? Because this fader is named data 1. So if we go here and we move this dial, data 1 is going to control the fader called data 1. And now I want to show you something. If I go to another, let's say an empty, MIDI track, and we load here a device called, let's say, LFO single, and we have so if we go to if we map this thing into the data 1, now the information from this LFO, it's going into the mapping. So, and this thing is receiving the information from data 1. But this is not the only thing we can do with this. So let's say we go here and we load a sample, and our collections, we go to green, let's a rhythmic noise, or rhythmic noise, this guy, and we hit loop, and we loop length just like this, and we hit start, we hit start. Now if we go to the device collections, and we add an envelope follower, this thing is automatically sending data to number 1. This is why this is doing crazy things. If we select number 2 and we go here and we name this fader to data 2, we are receiving the value from the OSC, from the envelope follower, and we can increase the gain and we increase the fall, and this fader is just moving from the information from this sample that we are playing. We can assign this to a certain parameters inside Touch Designer or Notch to control our visuals and the linings of an stage, motors, whatever we want, and to control other parameters. We can then select this to be sending information for our CC file to control modular systems and anything like that. So with this device, we can really send information to different locations and different parameters at any point. So this is really nice because it gives you a huge palette of different things to be controlled inside and outside the push tree. I just wanted to have a complete solution for controlling systems, because I usually do live visual and audio performances with everything improvised in real time, so my visuals are not really pre-recorded or anything like that. I just generate every single thing in real time. So if I want to control, manipulate things or from the visuals, I just can hit one button to control a scene or something like that, and I want this information to be sent to the video software, the video program, video computer. So this is going to run in the same computer where I have the sound. So by using OSC, it's really a nice idea and a nice implementation of that thing. Okay, so we have another case study. So we have here the iPhone sitting over some kind of a refurbished hard drive mechanism with a spinning plate, and so right now this thing is transmitting always information of the compass, so not the acceleration but the compass. So it will give me information of the position of the iPhone, so I can map that OSC value to whatever I want. So let's do that with the grain size. So by the way, I'm using in this case the Granulator 3 mod version, which allows me to get into my different folders. So as you can see, we have the different folders I have in my system. So I can, as soon as I scroll down, it gives me the amount of samples inside this folder. So I can load random samples from that folder. I can load random samples from different folders. I can do whatever I want. So in this case, I have one already loaded. So I'm gonna hit, as I said earlier, I hit select and the parameter I want to control. So in this case, it's going to be the grain size. And as you see now, it changed as soon as I hit select, because right now it's giving me the position of the iPhone itself. So if I go, for example, in this case, in that position is probably the change. So right here is the position of the 0 degrees. So it will change now to 360. So now it has been, I have a clip with a single note loaded, so I can hit play. Now as you see, is pretty sensitive because it really is reading a huge amount of data. Is really accurate in that sense. I mean, we can really get, that really is really sensitive. I mean, it depends on the device that you are using, but usually that doesn't have to do only with the iPhone. You can use Android devices and you will get also a really accurate position. And as you see, you may have old phones with the same application, with the same app installed, and every single phone can give you different information, so you can mangle things with really cheap devices.